Hi, this is Mr. Max. I'm doing part 2 of my work on further trigonometry, and you can definitely also go through all other videos on the channel, and please subscribe to the channel. If you do so, then I will definitely say, okay, I'm going to upload more so that I can make this project work. Okay, but if the moment I realize no, there's not a lot of subscribers, then like, okay, well, maybe it's not necessary. Okay, just some of those things that one has to do. Right, you have an angle alpha, and you're told that it's an acute angle because it lies between 0 and 90 degrees, and it's such that 2 tan square alpha plus sec square alpha is equal to 5 minus 4 tan alpha. And then we're supposed to show that we get 3 tan square alpha plus 4 tan alpha minus 4 is equal to 0. But then they say we must find the exact value of tan alpha. So here's the thing. When they say find the value of tan alpha, it means you're not calculating the value of alpha, but you're going to find what that tan alpha is. So the expectation is that you're going to find tan alpha to equal to some number. Do you understand what I mean? That number can be a fraction, whatever the case may be. Right. So I don't know. I have my super hex over here, and I hope that this is just but one method I use in order for me to know my Pythagorean square identities. So I know that sine square x plus cos square x is equal to 1. The other one that I could find here is I would be probably saying 1 square, which is just 1, plus cot square x is equal to cosecant 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 square x. Okay, right. The one that I'm interested in is this one, the 10 square. I'm going to use alpha, so 10, because I'm going this direction. Okay, 10 square alpha plus 1 square is equal to sec square alpha. This is what I'm going to use over here when I have this sec square alpha, because this sec square alpha over here, I'm going to replace all of that by this. Okay, because that is equal to sec square alpha. Okay, so I'm going to replace all of that sec square alpha by this. All right, let's start. So you have 2 tan square alpha plus sec square alpha is equal to 5 minus 4 tan alpha. Then I have 2 tan square alpha, and in the place of sec, I'm going to replace it, as I was saying, by tan square. Oh my goodness, that is tan square alpha plus 1. Okay, and then this is going to equals to 5 minus 4 tan alpha. Okay, this thing is going to become quadratic anyway, so let's see if we can definitely remove the brackets, and you're going to have 2 tan square alpha plus tan square alpha plus 1, well, minus 5 plus 4 tan alpha, because everything is equals to 0. Remember I said you're going to have a quadratic quadratic trinomial. So that is 3 of the tan square alphas here. Let's bring the 4 in its proper place, 4 tan alpha. And 1 take away 5 is negative 4 is equal to 0. And I think this is what we required to prove. Okay, so that is what they were asking us to find. 3 tan square alpha, okay, show that that is equal to, so 3 tan square alpha plus 4 tan alpha minus 4 is equal to 0. And of course we've done that. So that was what that one was, but there is a conjunction and we have to find the exact value of tan alpha. Now that means we have to obviously, this implies that we have to, take that quadratic and then factorize it, and then of course solve for tan alpha, not for alpha. Okay, so I hope by now you don't have a problem with this, but I'm going to take the long route. I know that you have 3 times 4 is negative 12, so you have got going to have 6 tan alpha. That's going to be plus 6. Okay, let's hope that we cannot have any problems. 6 tan alpha. Then you have minus, okay, minus 2, because that's a negative, minus 2 tan alpha, of course, and then it's negative minus 4 is equal to 0. So factorize, take out the 3 tan alpha, you're going to be left with tan alpha plus 2. And then if I take out a negative 2, then I'm going to get the same thing, tan alpha plus 2. Okay, should be familiar right now. You don't have to use the quadratic equation formula for all of this. So this gives us 3 tan alpha minus 2 in its own bracket. Okay. And then we have tan alpha plus 2 in its own bracket. At the end of the day, if you have the product of two things give you 0, it implies that one or the other is equal to 0. Okay, tan alpha plus 2 is equal to 0. Here, if you isolate tan alpha, you're going to get 2 over 3. Or here, you're going to have tan alpha, which is going to be negative 2. Now, you have to quickly do a few things here. First of all, and this is where I say to the candidates, they must read the questions carefully. Here it says, find the exact value. That's not a spelling mistake. I got values here. That is a hint when you read the stem that you must understand that there is probably one of these solutions that you will not be considering. Now, what will be your guiding factor? Your guiding factor is all of this over here. Okay, let's just grab it. Take a snapshot. All of this there, they are telling you the angle is acute. Okay, so when the angle is acute, let's take that. Right, when the angle is acute, just bring it over here. The tangent ratio from cast, if you may use the cast diagram, of course, you know that the cast diagram, okay, the cast diagram, the tangent ratio is positive in the first quadrant and positive in the third quadrant here. But our domain, we are told that the angle lies between 0 and 90 degrees. So this number here will not work because here is negative. So the only viable solution is that tan alpha should equal to 2 over 3. This is what we are looking for, and this is your solution for the hence part of the question. I hope that makes perfect sense to you so that you don't end up, using the wrong concept. Now I'm going to definitely use that question perhaps because this is part A of the question. All right, so let's dive into part B. It is given that angle beta is such that cotangent of alpha plus beta is equal to 6, right? Without using a calculator, find the exact value of cotangent of beta. Very important. This is exactly the same scenario that I'm going to introduce here, or that I'm going to elaborate or emphasize, that cot beta should be a number, okay? Because we're not looking for beta in this question, okay? We are looking for cotangent of beta. What is going to be that ratio or that number, okay? Right, so let's write down what we have. We have cot alpha plus beta is equal to 6. Now, here's something that you should know. You should know that a cotangent, okay, the cotangent, the reverse of it is the tangent. So I'll be writing that, and since I'm taking the reverse of that, I'm just going to take the reverse of this number, okay? Now, what is it that we now know? And I've introduced here your sum formula, the compound angles when you deal with trig. So I'm going to use that, okay? But I'm not going to put A here. My A here is represented by alpha, and my beta is obviously represented by beta, okay? So using that, I can clear this left side and I can say, wait, this is the same as tan alpha is a plus, so it's going to be plus on top, plus tan beta all over, okay? And that's all over what? 1. So that was a plus. We're going to have 1 minus. That is why you have the plus and minus here. It's very important because if you have to rely on using the formula, then please make sure that you copy the formula correctly. And then 10, and my alpha here, my A here is alpha, times, that should be multiplied by 10 beta. All of this should equal to 1 over 6. Now, let's go back and grab what was our previous solution. From our previous solution, this is what we know. We know that tan alpha is equal to 2/3. Okay, because they are saying here, without using a calculator, find the exact value of cot beta. Now, cot beta is the unknown that we are supposed to find, but how are you going to find tan alpha? And tan alpha, we already calculated it. So everywhere where I have a tan alpha, okay, tan alpha, I'm going to substitute it by 2 over 3. I hope that makes perfect sense to you. Okay, then there is a little bit of algebra work that is involved, and you take it from there. Okay, so tan alpha is going to be replaced by 2 over 3 plus tan beta. All of this, 1 minus, again, tan alpha is 2 over 3. Then multiply that by tan beta. This should equal to 1 over 6. All right, you can actually go ahead and whenever you're dealing with expressions that you put them in parentheses. This should be something that you are used to by now. Right, remember our objective here. What we are going to get here, we're going to calculate tan beta. So what we're going to get tan beta, whatever that tan beta is, let's say tan beta is A over B, just an example. Then when we're going to find cot beta, it will be B over A. So this is very important that you do understand towards the end that I'm going to get whatever that answer is for tan beta. I'm going to take the inverse of that because that is cotangent. Okay, now, so again, just cross multiply if that is the concept that you want to apply. The idea is to make tan beta the subject of the formula. So this is 1 minus 2 over 3 tan beta. Can remove the brackets because I'm just multiplying that by 1. Now I must collect the tan beta terms, but before I do that, I'm going to multiply out. So if you multiply here, this is going to be 3 into 6 is 2 times that is 4 plus 6 tan beta equals to 1 minus 2 over 3 tan beta. Okay. Now, where are we at now? So we are going to say, okay, let me collect the like terms together. So I have 6 tan beta plus 2 over 3 tan beta equals 1 minus 4. Okay. Now, of course, you can grab a calculator by adding those coefficients, but I expect at this level, a person who needs to add this is 6 and 2/3, and then becomes 20 over 3. This is very important that you can do that. Of course, you can obviously use a calculator, but I want to show you where is it that I'm going to get my 20 over 3 from. So this is 20 over 3 tan beta is equal to -3. Okay. Right, you can see it simply is getting better. So what is it that we need to do? Then tan beta, I'm going to multiply both sides by the reciprocal, okay? And the reciprocal of 20 over 3 is 3 over 20. Okay, hopefully we are together so far. Right, there are many ways, but then tan beta is going to be -9 over 20. But remember, this is not what we were required to calculate. We were required to calculate cot beta, and I said cot beta will be whatever tan beta is. I'm going to take that ratio and I'm just going to flip it around. So therefore, the cotangent of beta will be -20 over 9. Okay, and hopefully that inspires you in order for you to be able to find our answer to this question. Let me just go ahead and put it in a box, like to box things towards the end, telling the examiner, okay, this is my solution. Okay, what is it that, so that it's not lost within your working, because there's quite a lot that you will be doing, okay, as you work through the question. So you see that I've applied the compound angle formula for tangent, and how we use those numerical values for tan theta or tan alpha from the first part of the question, and how you are supposed to carefully read the question in order for you to be able to solve a question of this nature. Right, that brought me to the end of part 2. Stand by for part 3, which is an exam question paper that I took a question from an exam paper, so you can see how it's asked.